Well, everybody, it's crazy. This is just unprecedented, never experienced for generations, century. Probably a century. This kind of thing. So I'm gonna try to keep it as normal as possible, and really just kind of stick to the basics and going to make these videos quick and to the point and just basic skills, fundamentals to keep us moving forward. And that's all we can really do because it's weird. And I could give you links to other people that would explain it, maybe perhaps better, same way. I don't know. I encourage you to look for that. What we're going to do today is Radian Measure. And you just finished a test on rational functions and absolute value equations and those things. And now we want to go into advanced trigonometry. You studied trigonometry in geometry, and one of the things that you guys always worked on in geometry was angles, right? You had triangles and you had angles, 30, 60, 90, right? 30, 60, 90. You had 45, 45, 90s, right? Like those added up to 180 degrees. Those are your basic triangles, right? Those are your fundamental triangles. And like you didn't kind of know exactly why why are these so important? Maybe. But if you go to Michael's, everybody cuts cloth at like 30 degrees, 60 degrees, 90 degrees, or 45 degrees. I mean, that's just a normal. It's just a normal kind of cut. When woodworking, these are the kind of angles that you want to use, right? They're very normal. They're very basic and fundamental. And so what we did is we made triangles involving these, right? So that this was like the 60, this was the 30, and then this, of course, was the 90. This guy was the 45, this was the 45, and that was the 90. So they added up to 180, each one of them. What we want to do is we want to now understand angles in a different way. We want to measure them differently. All right, and now an engineer wants to kill two birds with one stone. They want to actually measure an angle by the length of the circumference, right? So, for example, we're gonna stop using degrees. Okay, we're gonna actually. I mean, you can use degrees, obviously. Everybody talks in 45 degrees, 90 degrees, 30, 60 degrees. I mean, we always talk in degrees. But what we want to elaborate on that and actually have a system that is a terrible circle, but it will serve our point. What we want to do is we want to start thinking about what is the circumference of this circle. And now I want to measure an angle by how far I go along the curve. Okay? How far I go along the curve will tell me what angle I'm at, which is two birds with one stone. Like, it's not only telling me the angle, okay, if I can adjust my brain, I can actually adjust how far I'm going along the curve, and it tells me what my angle is at the same time, which is pretty awesome, right? That somebody thought about this. So what we do is we start with a standard. We start with a standard and say, like, okay, yeah, my radius is 1 unit. Okay? And this is what's going to be called the unit circle. And this is a terrible unit circle because it should actually be a circle and not this warped version of something of ovalness. So what we're going to do is we are going to calculate what is that distance around the circle. All right. So the circumference was always measured by 2 pi r. Okay, that was a basic formula from middle school. The circumference of a circle equals 2 times pi, which is a number, right? That is 3.141592654. I'm not showing off. I'm just telling you I've done this so many times that I know pi to 10 digits. So this times that times the radius gives us the circumference. Now the radius we just said was 1 unit. It could be 1 mile, 1 meter, 1 foot. It doesn't matter. As long as we keep it in those units, we're going to have 2 pi times 1, which would be 2 pi itself. So the circumference is 2 pi. How many degrees is that? How many degrees is going around a full circle? Good. It's 360. Okay, 360 degrees. So what we're saying is that 360 degrees actually equals 2 pi. That's our standard now. So if I say spin around in a circle, no, not anymore. In pre-calculus, we're going to say spin around 2 pi. That's 360 degrees. That's our standard now. So if I say spin around 180 degrees, or let's say about face, what are you going to do? How many radians are you going to turn around? Think about it. That's right, 180. So it means then that 180 degrees represents an about face. All right, it's pi radians. Radians are not degrees. It's now you're shifting your thinking. You're not going 360 degrees. You're going 2 pi radians. All right. So when I say go 180 degrees, if I'm facing this direction and I want to go 180 and face this, okay, 180 degrees is pi radians. So here's our equivalence. 180 degrees equals pi. And that's our foundation. If you can remember this, then you actually know every single degree possible in radians. Okay? So now let's actually draw a better circle, or at least attempt to draw a better circle. Whoa, this video is already 7 minutes. Okay. So here we go. All right, I'll go with it. Okay. Okay, so we already said this is 180 degrees and it is pi. We said this was 360 degrees and it is also 2 pi. So what's 90 degrees? Very good. It is 180 cut in half, right? And if I already said that 180 was pi, well then 90 degrees equals pi cut in half, pi over 2. If I said that I want to go to 270 degrees, which is 3/4 of the way around, right? So what we're saying is that this is 3 pi over 2's. So this means that every 90 degree turn is a pi over 2. This is also another pi over 2, which is 2 pi over 2. And notice, cancels out. So I go another pi over 2. Pi over 2 again is 90 degrees. So that's 3 pi over 2. Oh, there we go. That's 270 degrees. If I go another pi over 2, that's a total of 4 pi over 2's. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2's, and those cancel out to 2 pi. So every 90 degrees is a pi over 2 radian measure. Okay? So pi over 2 is an essential. I mean, pi over 2 is 90 degrees. And what that does is it actually tells you that this distance right here, if your radius is 1, this length is pi over 2. Okay? So if I want to go 3/4 of a circle around, it is 3 pi over 2 radians, which not only tells me the degree now, because I don't want to think about 270 anymore. I want to think 3 pi over 2. 3 pi over 2 radians is the same as 270 degrees. All right? Because we're now changing from angle measure of just degrees to angle measure in circumference. Okay? And if I go all the way around, I've gone 2 pi, which is exactly what we found up there. 2 pi when you have a unit circle. And I don't care if it's a mile, a foot, a meter, centimeter, millimeter. It doesn't matter. It's going to be 2 pi units. Okay, that is the full distance around that circumference. Okay, so now let's get to like where we're going from here. What we want to do is we want to convert any degree measure into radians. All right, so here we go. So if I want, say I'm freestyling here. Let's say that I want do 135 degrees. Okay, and I'm an engineer. I don't want 135. Nobody's talking about 135 degrees anymore. They want it in radians because it's, again, killing 2 birds with 1 stone. What I do is I think of, okay, well, if I want 135 degrees, I want to multiply, okay, I want to multiply by a scale factor. The scale factor goes down to this guy right here. This is it. This guy is the fundamental. This is it. This is everything you need to know about radian measure. So if I want to go to 135 degrees, if I want to convert him into radians, then what I say is, okay, if I know that this distance is pi radians, what portion is 135 degrees? And so what I do is I multiply by a scale factor. And that scale factor is pi over 180. Okay. Now notice I am putting the degrees because what's going to happen is when I multiply these 2 fractions together, mind you, this is just 2 fractions. These units will cancel out, and I want the degrees to cancel out because I don't want to talk about degrees anymore. I want to talk about pi. I want to talk about radians. Okay, pi radians. So every radian measure should have pi in it 90% of the time. Rarely is it in decimal form until calculus, all right? But right now, when we're focusing on this unit, we're going to focus on, how do I look at angles in terms of pi radians? And so now the degrees cancel out, okay? So let's think. Pi is now introduced. I want to figure out, I'm going to multiply the fraction actually. I want to figure out what is 135 over 180. What is 130 degrees? What portion of 180 is he? Okay, so I think about what will actually go into, what will go into both of them, common denominator. So let's go 5. 5 will go into, let's see, 135 twice, and then 5 will have a remainder of 3, 30, 27. So then 5 will go into 180. It'll go into 18. It'll go 5 times 56. Trying to do the math in my head real quick. So we still have pi, and I keep reducing the fraction. Will 3 go into both? 3, 1, 2, 3. No, I think that's it. Oh, shoot, do I have my calculator? I don't. Just want to be careful. I do believe that 56, okay, that's 3 times 7. I'm sorry, 3 times 9, and then 56 is 7 times 8, which is 2 times 4. So, yeah, untouchable. This is it. That's your final answer. 27 pi over 56. What that does is that tells us that if we broke up pi into 56 pieces, then, which is this right here from 0 to pi, if I broke this guy up into 56 pieces, 135 degrees is going to be 27 of them. Okay, right about there. Okay? That's our new measure. So, again, 180 degrees equals pi radians. Now, this was kind of off the cuff, and I wish I wouldn't have used such a, I thought 135 would be really kind of breakdownable. So let's try another number here. Let's say that I have, let's go with, okay, I'm trying to do this off the fly. And we're pushing the 15-minute mark. Let's go 180, 150. Okay. All right. Now I know 150 is between 90 and 180. And so he's, I don't know, somewhere around there, right? Somewhere around there. If I'm measuring from here to there, right, to the angle, this is 0 degrees, 0. 150 is probably somewhere, but I don't care about that now. I want to get into pre-calc mindset, and I want, what is this in radians? And so the radians, I have to bring pi into the picture, right? Because I don't want to think about degrees. I want to get rid of the degrees, all right? So that this and this cancel, right? Linear analysis or dimensional analysis. And I want to introduce pi as the equivalent of 180. So now what I can do is think, okay, well, I have 150 pi over 180. So just reduce. There you go. Divide by 10, fine. Looks like 3 will go into both. So 3 is 5 times, and here is 6. So 5 pi over 6. So this means that if I were to break this guy, in fact, let me draw a new circle here. If I were to break this guy into pi into 6 pieces, 1, 2, 3, 4, 5, 6, 150 degrees would be right there. Right there. Okay. So that's our new standard of measurement now. All right. Now, there's negative angles. We'll talk about that another time. Right now, I'm going to stop it right there. We're at the 17-minute mark. So I'm going to go ahead and just put, I'm going to put 20 problems that basically take a degree and introduce pi into the degree. Get rid of the degrees. Change your mindset into thinking, I don't want just this measurement here. I want this circumference around. Okay? So this means that 5 pi over 6, if this was 1 mile, okay, this distance from here to here is 5 pi over 6 miles. Okay, that's great. It's like not only are you getting an angle measure out of it, you're also getting that distance, okay, that arc length that you were, measuring in geometry. Okay, all right. So I'm going to go ahead and there's going to be a worksheet for you guys to practice this. Radian measure is integral to the SATs, so I'm going to give you 20 problems for you to practice. Well, tonight, probably not, but tomorrow night, okay? And if you have any questions, just go ahead and leave comments. Seriously, don't email me personally. Leave a question in the comment. Like, I would want everybody to know your question. It's like raising your hand in class, okay? You guys are a smart group of people, so just chime out, throw it out there. I'm going to give you the answer key tomorrow night, all right? So not tonight or during the day, but tomorrow night so that you guys can kind of practice it first and then, check your answers, all right? But that's Radian Measure. That is the essence of Radian Measure. Okay, a little sloppy, all right, but I think it'll do. And again, ask questions. All right, have a good night and be safe.